let's make it go. So good morning again, ladies and gentlemen. Thanks for joining today's Actuate webinar. Like you know that under the Participate series of the RECIRCULATE ACTUATE program, this month's theme is actually celebrating important outputs and successes of the ACTUATE project. And obviously it's a waste to energy webinar. And the theme is just to showcase waste to energy solutions in Africa with emphasis on the ACTUATE project. So we'll be hearing from our Nigerian and Ghanaian partners on what they've been up to for the last couple of years. Ultimately, you will remember that we've had a series of other workshops previously where we've spoken about the fundamentals of waste management and anaerobic digestion, but also we always told you about, if you like, the different activities happening in both countries with respect to the project. But I think today, for the first time since the project began, we can actually showcase what they've been up to. For those who were wondering, maybe nobody was doing anything. Yes, they've been doing some incredible work, and we're hoping to use this meeting to showcase this. Now, it's an open forum for folks who want to ask questions and how was it going to. And by the way, I'll be putting the partners into into a tight corner by asking them open questions, or maybe things people are thinking about, wanting to know. So how was it planned? What was the political dimensions? How did COVID affect things? All those kind of things. We're hoping we can get through those today. And ultimately, the idea is to get people to understand that once a project begins, especially of this nature, what are the benefits, challenges, but ultimately, what are the expectations, and how can you build legacy and sustainability around those projects? Now, I don't want to take so much time today. We're hoping we can wrap it up quite quickly, but I think the first thing I want to do is get Kirk to give us a sense as to the ACTUATE project and /RECIRCULATE, and then give us an idea of where the project is going, potentially what the next steps might be. And then on the back of that, we can invite Nigerian and Ghanaian partners to go at presentation. So on that note, over to you, boss. Kirk.
Okay, thank you, Akan. So what I'll do is before I introduce myself, I'll share my screen, if that's okay. So just bear with me, please. Okay, so can folks see that?
Yeah.
Yes, open up.
Yeah, just put it on presentation mode. It's taking it. So can people see it in presentation mode?
Yeah. Yeah.
Okay, excellent. Okay, well, good morning, everyone, and thanks very much for joining the webinar. It's great to have you on the call. So some of this will be familiar, some of it not. But so my name is Professor Kirk Semple, and I'm the director of both the RECIRCULATE and ACTUATE projects. I'm also heavily involved in a lot of international activity within my department, Lancaster Environment Centre, Faculty of Science and Technology, and the wider university as well. Now, what I'm going to do here is give you an introduction to the ACTUATE project. So, under the grand heading of Waste to Energy Solutions in Africa, accelerating the adoption of circular sanitation demonstration systems for improved health outcomes, shorthand ACTUATE, is actually a demonstration project funded by the UK government's Global Challenges Research Fund, and has been running since October 2019 and will end, unfortunately, at least in this incarnation, at the end of the year. So just to take a wee step back, globally we have a pretty negative view on waste. We see it as valueless. And in the sort of sub-Saharan African context, huge tonnages of waste are produced on an annual basis. And a lot of that waste is actually composed of organic material, organic wastes, which normally end up either thrown away in the environment, open dumps, landfills, that may be burnt. But ultimately, this results in environmental contamination, which has massive implications for not only the health of the environment, but also the health of the populations as well. And we know that sanitation is particularly important here and can contribute to significant illness in children, and unfortunately leading to death as well. So it's clear that this is a significant global challenge, and we need to address ways in which we can use sustainable solutions to remove this and actually, in fact, take advantage of the waste. So how do we do this? We think about the circular economy, in particular the wastewater, energy, food nexus, where we're looking to reduce the amount of waste that we actually throw away. Okay, so we're adding value to waste. So through the circular economy, we focus on the 4 R's of reduce, reuse, recycle, repair, and refurbish, to actually manage out the waste from from the circular economy. So to do that, partnership is very important, and we've been working with our African colleagues and partners for a number of years now, to mainly through the research lens, but also through engaging with private sector and policy to generate transformational impact that's actually really relevant to communities. And one of the ways that we can do this is through eco-innovation, applying eco-innovative thinking to develop new products, processes, interventions and services that benefits both society and, of course, the environment. And of course, that's not a monolithic sectoral activity. It involves cross-fertilization, cross-thinking between research communities, industrial sector, government and policy sector, and of course, civil society and community as well. And one of the premises that we've developed that underpins this is this notion of co-design, co-development and co-delivery. So ACTUATE has emerged from the research and capacity building elements of the RECIRCULATE project. So RECIRCULATE represents the mothership. It started in 2017 and will finish at the end of March 2022. And this has been a really dynamic and productive collaboration with numerous countries in sub-Saharan Africa, working with colleagues at Lancaster on this notion of driving eco-innovation in Africa and capacity building for a safe circular water economy. And it's really out of this, as I've said before, that ACTUATE has emerged, thinking about how we can take the research and capacity building from RECIRCULATE and actually apply it and hopefully deliver some tangible impact that's actually of value to society and the environment. So how do we do this? Well, we've built 2 demonstrators, one at the University of Benin campus in Nigeria, the other at the Umar bin Khattab Islamic School in Accra in Ghana, and working with partners in both countries. And by building these demonstrators, we have ways of showing that the technology is relevant, it's important, and it actually works and can be adopted across the piece. So we're looking at solutions to the problems that we face that I've already talked about. We're talking about education, whether it's at school or university, to generate and gain acceptance within the communities, and for people across the whole project and the countries involved to embrace the notion of the circular economy. And also, of course, to think about how we can develop entrepreneurial activities and thinking and opportunities to maximise the economic and social benefits of what we're trying to do. Now, it's important that I introduce the teams. Of course, the colleagues at Lancaster across all of the faculties are involved, multidisciplinary, of course, and that applies to our Ghanaian and Nigerian colleagues as well. So we have the Council for Scientific and Industrial Research, the Umar bin Khattab Islamic School, the HATOF Foundation, Green Advocacy and Sewerage Systems Ghana Limited, all in Ghana. And in Nigeria, of course, we have the University of Benin, the Centre for Global Eco-Innovation in Nigeria, of course, National Centre for Energy and Environment, and the Nigerian Environmental Society. And the other thing that I want to point out is that the Recirculate and Actuate projects and the other projects that are emerging from this are really beginning to strongly focus on many of the UN Sustainable Development Goals. So, lots of engineering, lots of development of demonstrators to you know, show what we're trying to do. But there's lots of activity in working with communities as well. So schools, universities, research institutes, NGOs, SMEs, policymakers, all highlighting and focusing on the circular economy and its positive impacts as shown through our demonstrators. The benefits to human health and the environment, and how we can develop safer and more sustainable practices across all of the stakeholder groups. And of course, beyond the funded projects, we want to maintain these activities. So how do we do that? We think about investment, we think about commercialization, engagement with SMEs and entrepreneurs to support and develop fit for purpose and robust technologies that work within the communities, but also to offer up training opportunities for interested stakeholders to manage and support the continued use of these technologies as well. So just to finish off, to highlight the Dream Team. Okay, so what we have here is a fantastic webinar that's going to showcase the activities across the two countries and the key players involved in there, coming from slightly different perspectives. This is really important because it's the first opportunity to actually show what's being achieved now, which is fantastic. Okay, so I'm going to finish off now. I'm going to hand back to Akan, but if you are interested in these projects, please look at the websites as well. So thank you very much, everyone, and back to you, Akan. Thank you.
I'm going to ask you questions. So obviously, microphones, please. Thanks, guys. So I'm going to put you on the spot. I'm going to ask you a few questions before you run away. I know you're not running away, but obviously, as a director, you're muted.
There we go. I'm not muted anymore.
Director of the project, could you paint us a picture of, if you like, what made you apply for Actuate as a proposer, a project in the first place? Obviously, Recirculate as a project was running. Why was it important for you, from the point of management or strategy, to apply for this particular project? Could you answer that, please? Thanks.
Okay, so I mean, what was going on and continues to go on in Recirculate is absolutely fantastic. It's so multidimensional, but a lot of it focuses on, and I guess I'm sort of thinking from the waste to energy perspective rather than the food security perspective. That there was, we were missing that final piece. So there was a lot of great stuff going on in the labs at UniBen and CSIR at Lancaster on experimental projects, relatively small scale. And what was really missing was that sort of link between what was going on in the universities and the research institutes at relatively small scale to the real world.
Okay.
And actually, the funding that became available for Actuate offered that opportunity to take that sort of lab, relatively small scale research and apply it at a much greater scale. Okay. And of course, scale is important because you can support communities from, systems that you're using in the laboratory.
Sure. And
it's really difficult to convince communities, stakeholders, companies that it's going to work in the real world. Okay. So it was a really important step for us to engage with wider stakeholders and show that it was working, okay, and to get on board.
So let me ask you, so obviously it must have been a difficult ride. So what were the key challenges in making a project of this nature? thinking from a point of management as a director on the project, what were the key challenges you'd faced in making this happen? So we're about to watch a few videos and pictures that actually what began as an idea, a concept, a proposal is now physically on the ground. And by the way, I will get to see it before you physically because I'm off to Benin today. But my point is, I know you're jealous, but that's fine.
I am very jealous.
I know, but my point is, what really is what are the biggest challenges you faced as a director on the project?
Well, I mean, it doesn't take a genius to say that the biggest challenge that we faced was the impact from COVID.
Oh, COVID, okay.
As a starting point, because I mean, you know, you know, and people may not know, but I'm going to say it anyway. One of the strengths of the Actuate project is that we all know each other. We've been working together for a long time.
Interesting. Okay.
And so all of the sort of, you know, I know that there have been some hiccups and stuff like that, and there always are with projects of these sizes, but you know, the systems are in place for the movement of funds, etc., etc.
Okay.
But the you know it's I cannot emphasize this strongly enough. The willingness of our partners at the University of Benin and Accra and Kumasi to well, particularly Accra, obviously, because it's the Institute for Industrial Research that are really leading on this element. Yeah. Their ability to think round these problems, come up with solutions in spite of the challenges that COVID was throwing up, and also the massive support from senior management at institutions as well. Without that, it would have been a much more challenging ride. Okay, I think, and you know, I can't extend my thanks enough to that. So COVID was a challenge. I think, you know, the other challenge is that there is no one system that fits all. I mean, we all understand anaerobic digestion as a concept, right? And you know, engineers will say, well, you can do this, that, and the other. But actually, you know, there is no one specific model. You know, so the system in Accra at the school, although in principle is the same as the system at the University of Benin, they are actually different. They're different in size, and that brings all sorts of challenges as well. So yeah, COVID was a massive challenge, but you know, lateral thinking, massive support allowed folks to get around it.
Okay, so I'm going to try to open to the room. Does anybody have a question for the director? I mean, I know you've been inking, like kind of wanting to ask him something concrete, something big. Has he been playing for the last couple of years for the project? So if anybody in the room has specific questions for Kirk, please, now is the time to. And if you can pick it up right now, if you leave a question on the chat section, I'll pick it up afterwards and direct it to him. I'm hoping I can make it as interactive as possible today to have some specific conversation. So just thanks, Alan. Raise your hand if you have a question, and then you'll be let through. So if you have any question for Kirk, or if you have a question for him later, Alan, could you also let me know when someone raises up their hand, just in case I cannot pick it up? And I think then we can pick up those questions. So I want us to kind of interact appropriately in a sense, but also get to the nitty-gritty, a bit more depth as to the workings of making this thing happen. I think while we wait for questions for Kirk, I've got one more question for you, Kirk, but I'll ask you later. It's about legacy. So the plant is here. What do you see? What in your mind would make you a happy man after the plant? Don't answer it. I'll ask you later. Have that in mind. But I think for now, I want to invite our Nigerian folks and partners to give their presentation. Showcase the Nigerian project. Let's go. Is Mike on the call?
Yes, I'm on the call. Good morning, everyone.
Fantastic. So could somebody share Mike's presentation, please?
Yes, I'll do that in a second.
Beautiful. Thanks, Diane. So, okay, bear my question in mind here. I want to tell us afterwards what would make you a happy man. Now we have a plan. So what is the future? Yeah, have that in mind. I'll come back to you after we have Mike. All right, come on.
Okay. Let's tell this.
Mike, just patience. I think I just want to share your presentation. There you go.
Okay, good morning, everyone. I'm only standing in for Professor Lawrence, who is a team lead for University of Benin and in Nigeria. So essentially, this project started out as co-design and co-delivery sort of project. So I'd like to tell you a story around the project and where we are at the moment. Thank you. So if you go to the next slide, please. Next slide, please.
Okay, sir.
Okay, so it started out from an idea that was shared, as earlier said, co-design and co-delivery. And one of those things we started out doing was clearing the site and then beginning to think of, making sure that we're able to have a design for it. Before the construction. We also talked about the feed collections. What kind of feedstocks are we going to use to complement the recirculate experience from our feed cart to food and all of that in terms of the ratio, and also thinking about how we're looking for it to perform at operations and what sort of energy is it likely to deliver? What amount of energy are we looking to deliver? So we thought around all of these, and at some point we had to go into literature and theory to be able to have a proper markup of what power we're able to supply, looking at the waste that we're able to generate and also able to collect from the neighborhood. And again, looking also the research content, how we're able to integrate all our research actions, and then the training aspect of it. Who are those that we're looking to impact this project with? The university environment, the secondary, and then the school children that are starting their. Prof, are you?
Who is the person monitoring it? College. So what is the state?
Can I continue? Can I continue, sir?
Yes, continue, Mike. Prof, could you mute yourself, please? Go on, Mike. Please.
Okay, so so we have to look at the issue of performance. What energy amount are we looking to deploy, and then how we're going to be able to demonstrate these activities such that the secondary, the primary, and the tertiary institutions are able to benefit from it through training and workshops. At some point also getting them to have a practical hands-on on the experience that they've gathered from ACTUATE project and demonstrations. So these were the things we talked about, and we put that up in a timeline initially, which was to start from May. But where we are, we've been able to achieve this aim, but though with some extensions, which were mainly resulting from the COVID-19 and other contingencies regarding the project. Thank you. Next slide, please. So, as earlier said, this project of ACTUATE is translating recirculate into experience. So, which started out by making sure that the stakeholders are impacted through R&D, and then one of those things that this project looks to doing, which is already doing, is bridging the gap between the user community as well as the SMEs, those that are also looking to start up small businesses from our experiences. And then again, it gives us the opportunity to build research linkages across. As you know, that we have partners for this project from Ghana, Lancaster University, and others who has also been very useful to this project. So it gives us an ample opportunity to learn from across several research institutions and universities. So Okay, so that also enabled us to maintain a safe and clean environment through biogas generation from the University of Benin and its neighboring environment. And essentially, this also was also important in creating an alternative fertilizer from digestion, because it's actually a closed project, a closed cycle project, such that, you know, from waste we're able to generate energy from it, and as well also produce a biofertilizer from it through our digestion. So it's all recirculating around waste, which is something that we are very happy to deliver from this project. So next slide, please. Okay, so for those of us who are new in this project, the question that some of us be asking is, how is what is this thing called recirculate? So I'd like to just give you an idea of what we're trying to do through recirculate, which is accelerating the adoption of circular sanitation demonstration systems for improved health outcomes. And we are very thankful to the funders of this project, the GCFRO and the Global Research Translation Award. And we're also very thankful to the partners of this project. Next slide. Okay, so as earlier said, what is recirculate? What is actuate all about? So first of all, this project is taking place at the moment in Nigeria and Ghana, and all of these is co-designing a project looking at different focal points. So here we started out by looking at fecal waste, and very specifically cow dung, and then again we're also looking at food waste. You know, so at some point we also saw that we could also achieve this via poultry droppings and a few other ways, but our focus actually centered on food waste and cow dung. So what are we looking to do with this? What we're looking to do is to be able to produce bioenergy in form of biogas. So which this project started out for, and at some point in these slides, we will see how we're able to deliver our design. Next slide, please. So as earlier said, we don't want to assume that everyone know how this happens. So in University of Benin and our research concept, we're looking to produce this bioenergy through anaerobic digestion. And the essence is to recover resources from waste for health, energy, and agriculture. And essentially, what we're looking to get is biogas. We know that biogas has constituents that cuts across carbon dioxide, methane, and other gases. So essentially, the resource for this biogas is animal waste and food waste. Okay, and after the biogas is produced, we're not looking to just throw everything, every other byproduct away. We're also looking to look at it, which also is a complement of the recirculate experience, to see how much we can use this digestate to produce bioenergy, biofertilizer for agricultural crop production. So, which is also an important element of actuate, and also what we're looking to demonstrate at the end of the project life. Okay, next slide, please. Okay, so basically the entire process of anaerobic digestion is biological decomposition process that occurs in absence of oxygen. And they're just basically four main steps, which are hydrolysis, and the second one is acidogenesis, while the third is acetogenesis, and the last one is methanogenesis, where the methane is actually produced through the help of some bacteria that we have to work in the absence of oxygen to produce these gases that we're looking to get for energy reasons. Next, please. So we've tried to further conceptualize this into how our design should work. If we have a container which we'll call the digester, these 4 steps will have to take place for biogas to to be formed. And the outcome of these biogas is for electricity. On the other hand, it could also be used to generate heat via water heating up, and then at some point technologies can also take it to as far as powering our vehicles and automobiles, as well as also looking to collect the digestives, which we can now split into solid or liquid form, all of which could also be used for agricultural purposes. Thank you. Next, please. Okay, so this is the actual Nigerian process instrumentation diagram. So it started out from pretreatment. These ways we are picking up how we're going to be able to prepare it so that we're able to use it for this purpose. So we reckon that we also need to pick up this cattle rumen, the dung. So how we're going to prepare it, how we're going to be able to use it. Do we have to use it raw, or do we have to use it in some form after applying some form of treatment to it? So these were some of the considerations that we have to make. Essentially, in this case, where they were collected and the sizes of the content were reduced through maceration, and we reckon that there has to be a storage. So we have a system wherein we have to store some of it in our storage tank. And because of the safety considerations, we also an issue of pathogen. We introduced the pump to avoid the physical contact with this feedstock. So from the storage, the pump is useful in transferring this content into the next tank that we call the batching tank. And essentially, we also do need to stir to maintain uniformity in the mixture. So that we do through an agitator. And again, we also have to introduce a submersible pump there to be able to transfer this batched amount of feedstock through to the digester. So we do have pumps separating the two digesters, right? So from digester 1, we hope that feedstock pumped from the batch tank is able to get to the digester 1 and the digester 2, which could be simultaneously or independently. So, and this we also planned out, knowing that at some point these digesters has to be emptied. So we have a slurry where we can be able to remove some of these spent feedstock and be able to use them for further studies regarding the digestate, and I'm able to see how much of these digestates we're able to recover from the system. So again, for digestion reasons, these feedstock are to be allowed to stay for minimum of 20 days in the digester, and then when it's allowed for this period, microbiological reactions will take place, leading to the formation of these gases. So again, we know that gas formation is accompanied with some moisture. So at some point, we also need to be able to strip off some of this moisture, and also making sure that some impurities like sulfur that may be associated from some of these feedstock, especially for cow dung, wherein we know in Nigeria is coming from far north of Nigeria, and in the process they're exposed to vehicular emissions and inhalations into their system. So we know that definitely there's going to be some amount of sulfur in their system, which may also impact on the gas that will be produced. So we introduced the desulfurizer to remove this sulfur compound from the gas, which may inhibit our biogas and also cause some form of corrosion in our engine if not removed. So these were a few things that we have to consider to make sure that we have the purest of the biogas produced. Okay, so we also have a compressor such that we're able to increase the level of pressure that the biogas will be transferred from the gas bag to from the digester to the gas bag, and from the gas bag to the generator. So these were made possible through compressor, which is rated 1 horsepower, at the most. And then we could see how we're able to also transfer the power generated from the generator to the building, which is a CGE building for power reasons, which is very key, because here we know that at a lot of times in Nigeria, we usually experience outages. So this project is very useful to meeting up with the light consistency, especially for our team members who have to work around the clock to meet up some of the research challenges. Next, please. Okay, so what's our goal? All of these discussions, what does it lead to? First of all, I'd like to let you know that the digester size is 30 cubic meter of feed was planned for, so, and if we plan for 30 cubic meter of gas, we also know that gas could be under or more. So we also have to plan for certain amount of storage level. And in this case, we stored 30 cubic meter of gas storage bag to be able to collect some of these, evacuate some of this gas produced for storage, and such that we'll be able to assure ourselves of gas availability anytime we need it to run our generator. What's the capacity of the generator? 6.5 kVA biogas generator. Okay, and this is looking to be able to feed the plant for 8 hours per day, which covers the active hour of a typical. So these are the things we have. And then from the measurement of our biogas purity, we've been able to, over a period of 3 weeks, we've been able to assert that our gas purity is between 69 to 75% purity, which is, overwhelming, because a lot of literature will state from 59 to 69 thereabout. But from what we're getting from our flow metering system, we've been able to record up to 75%, which is fantastic from the records that we've kept in this research. So again, on the environmental side of things, imagine using waste biodegradable food for biogas production, and then be able to deploy the waste from the abattoir for energy production. And again, if we continue to pick up this waste by food waste weekly or bi-weekly, it is expected that at some point we're able to remove 7,500 kilograms of waste from the environment, which is a massive environmental management system. So I think we've really achieved this and beyond, because in terms of consistency, we need a lot of waste, and this number is at the moment far surpassed. So we hope that we'll be able to update this record in a short while. Thank you. So next slide, please. So essentially, this is just the physical construction as built, from the mixing to batching, as we saw from the PNID. And then this is the digesters as installed. And then if you look at the third picture there, you will see the digesters showing outlets, because we do need to be able to evacuate the spent feedstock as digested. So this is how we collect it. So essentially, and at the moment, these lines are connected properly, such that we're able to also use it to monitor levels of the gas that is actually in the feedstock level in the digester, and also make sure that we don't have overflow for safety reasons, which is also one of the key recommendations of our HATOF studies. I like to say very strongly here that this research followed a strict HATOF study, which we have also tried as much as possible to implement in the process of this construction. So again, we've been able to test for different things in the process of constructing this plant. We've tested for leakage, we've tested for flammability, we've tested for purity, and we've also been able to test for engine capacity. How much of this gas is engine able to accept, and how much do we have to fill our bags to keep this engine running for how long and how many days it will have to stay running. Okay, so we've done all of these, and we can say that we do have gas available to be able to run this engine for, as proposed in our design specification of 8 hours per day. All right, next please. So in the coming slide, I would like to show you how we've been able to use this how we've been able to use this gas to run this generator. So next, please. No. If you need to play the video, so we need to see how it's running on the slide, and leave it running for some time, please. Yeah. Perhaps if you let the sound come out, so we could see. Yeah. Okay. So I don't know if you are hearing the sound where you are, but this is exactly what we've been able to achieve. You could see that the process is comprehensive, and we've been able to use it to run our generator as long as and anytime we want it running. So we have a backup, we have a sustainable backup, and we've been able to meet our goals. Thank you very much for listening.
I think that's fantastic. Thanks so much, Mike. And I mean, that is a lot of work, especially considering the different obstacles and challenges that COVID has brought in, but also different logistic challenges to kind of put this together. And obviously, one cannot overemphasize the significant contribution of the management and leadership at University of Benin, but also the key partners to actually make this happen. I would imagine if anybody has any questions for Mike and the Nigerian team, please, like I said earlier on, just raise up your hand and Alan will spot you. Then you can ask your questions, or just leave something in the chat section. I will try and pick it up. I'll come back to you with some questions, Mike, I think for the Nigerian team. But I think before I do that, let's hear from Andrew, who will speak towards the engagement aspect of the project. Obviously, they also won a £5,000 mini grant to do something exciting around engagement that contributes to the legacy of the project. So if Andrew can come in and give his presentation, then I can have a more generic question for the Nigerian team, and we can have some interactions with the audience through Mentimeters. Okay, Andrew, over to you, please.
Okay, I can. So if this slide can be put up.
Yeah, just a second.
Okay.
Can you see the slides?
Not yet.
Yes, we can see that. Andrew, can you see that?
I can see it.
No, I can't see it. Okay, it's coming up. It's coming up.
Okay. So Andrew, I'm sure you can start. Yeah.
Okay. So the slide is still not showing on this side. So it's just showing that it's trying to load.
I will try another way of uploading. Just give me a second.
That's all right.
Okay.
Sorry, should come up momentarily.
Is it possible for me to share from this side?
Okay, can you try? Can you try then?
Yeah, let me try that.
Oh, there you go.
So is it can you see it?
Yes, very clearly. Just fantastic. Yes, we can. Please proceed, Andrew.
All right. So good morning, everyone. And like Dr. Akan introduced, my name is Dr. Andrew Amenaghawon. I'm a co-lead on the ACTUATE project. When you listen to the presentation of Dr. Mike, it will seem as if the whole ACTUATE project is very, very technical, but it's way more than that. One of the key aspects of the ACTUATE project has to do with the code development and the co-implementation of the project. Obviously, when you look at the ACTUATE project, you see that it's actually a translation project on the back of the RECIRCULATE project. So that means it's actually a solution. And in looking at it that way, we want the solution to be fit for purpose. So that means that the end users need to be taken into serious consideration. So we don't want to provide a solution that will not be very useful to the end user. So in that regard, as the project has progressed, we have tried to carry these end users along, and that has resulted in many stakeholders engagements, which we have organized in the course of the project. So I'll just mention some of the undergraduate students within the University of Benin, waste managers, as well as smallholder farmers. So when you look at the whole life cycle of the project with respect to the useful products, the bioenergy, the digestates, and the waste. So all of these stakeholders were carefully selected to take advantage of those key aspects of the project. So I'm just going to go through some of the engagement that we have had since the beginning of the project. So we had an engagement with PIN. PIN is Partnership Initiative for Niger Delta. They are an NGO in Delta State in Nigeria here with serious interest in biogas technology. And from our engagement with them, what we have found is that they have been building 1 or 2 biogas plants here and there, but they have issues of they build these plants in a couple of months, the plant packs up, is no longer functioning. So we visited them, we shared ideas, we had knowledge exchange, and we were able to put together some ongoing collaboration in the sense of bringing our expertise into what they are doing to see how we can resolve some of those technical issues that we're having. So from the very beginning, the collaboration was very progressive and was very fruitful. So everything, majority of what we have been doing since they have sort of been involved, and all the majority of the workshops that we have had since that time, they were involved. So that is an ongoing collaboration that is currently on. Then we have the abattoir operators in Edo State. This actually kind of make a lot of sense because the abattoirs, they are our biggest suppliers of feedstock, because the ACTUATE project is built on the basis of using cattle content and food waste. So the cattle content comes from the abattoir. Obviously, it's an abattoir waste. So it made a lot of sense for us to on that, so that we can be assured of continued supply of feedstock. But we did not leave it there. So recently we invited them to the university, and we actually trained them on how they could use abattoir waste to generate energy. And they actually seriously in need of energy, because in roasting the cattle, what they currently use is not sustainable, and it has some health implications. So we're able to expose to them what we have done with the ACTUATE project. We brought them to our ACTUATE site, and they saw that we have produced gas, and we told them that this gas was produced from the waste that we collected from the abattoirs, and they were actually very, very excited, and they saw this thing happening in real life. So they started discussions on how we could replicate something like that in their abattoirs. Then we visited OSA greenhouse farms. This is a greenhouse farm in Benin City that they produce tomatoes, pepper, and other vegetables. And based on our discussion with them, we found that they generate quite a lot of waste. And we also discussed with them on the possibility of generating energy from their waste, as well as using digestates to grow their crops. So we had a series of engagement with them, and the discussion was very, very positive. So they are one of our collaborators, and we are still having progressive discussions with them. Then we visited a poultry farm in Benin. The poultry farms, they generate a whole lot of poultry waste, and that is actually very rich in organic content. And it's actually a very good feedstock for producing biogas. So essentially what we did was to tell them the value they can derive from poultry waste in the sense of generating energy and ultimately maybe getting digested from it and using for farming purposes. So we visited this poultry house, and the poultry operators, we spoke with them, and they saw a lot of sense in what we're doing. And the beautiful thing is that these engagements were always very practical, because there was a basis for what we're saying. We usually tell them that we have an actual plant in the University of Benin, and that's very, very real. So and any of these people that we visited, the discussions were always very practical, and the interest was seriously stimulated. Then, of course, the waste managers in Edo State, we brought them together. We did a training for them, and we also introduced them to the ACTUATE project. And the discussions, we had a breakout session where we asked certain questions to stimulate the discussion, and the discussions were very revealing, and we learned about some of their challenges. Ultimately, what we're looking at was to see how we can have a coordinated process to collect waste, which ultimately will be used for bioenergy production. Of course, we know that there are different kind of ways that these people collect, but the key thing that we wanted to take away was that we should start seeing waste as a resource from which we can derive value, not something that should actually be considered on something that we should consider useless or not useful. So we're able to do all of that, and we took them to the site, did at this demonstration site, and they actually saw what was going on there. And just like the other stakeholders that we invited, they were actually very, very impressed with what we are doing here in the University of Benin, and they were also interested in replicating such in different locations within the state. Then we invited smallholder farmers. Our interest in this case was to drive home the importance of digestate as a very safe and sustainable organic alternative to inorganic fertilizer. So we did that training some months ago, and we also did a breakout session where we had syndicated discussions and stimulated them, tried to get the ideas, try to ask them if they will accept digestate. Obviously, after going through the usefulness of digestate and all of that. So they indicated a high level of acceptance, that they will be willing to adopt digestate as an alternative to inorganic fertilizer. We even asked them questions like, if you were to use digestate, how much do you think it should be sold for, and all of that. So the discussion sessions were usually very, very stimulating. And just some weeks ago, we invited them back to have sort of like a feedback session, and also to assess the level of implementation of their gains and how they have been able to translate what they gained during the first workshop. And from what we got during the second meeting with the farmers, we were able to see that they have been able to translate some of the things that they learned during the first workshop. And what we actually saw, because this second time when we brought them, some farmers were attending for the first time, and we found a situation where the farmers that attended the first one, they were now the ones even training the farmers that were attending for the first time. So it was a very productive session that we had with them. Then we invited secondary school students around Benin City here, and we took different presentations bordering around waste management, specifically innovative waste management strategies in the 21st century. Also, presentations were given on the use of the digestates, as well as the generation of energy from waste. So we talked to these kids, and we were able to stimulate their interest. We asked them questions. We asked them to ask questions, and we were very, very impressed with the level of response that we got from them. And obviously, at the end of the session, we took them to the biogas plant. For this particular session, this was recent, and that means that the project was almost at the completion stage. Gas was already being produced, so it made a whole lot of sense to them. And when we went back for the close-up session, and we had some little bit of a questioning session, and then we found that these students were actually very, very interested in pursuing careers in the bioenergy. What is that these students are very, very productive, interested in going into something like this. Then USS and UDSS. USS is the University Staff School, while UDS the primary school, while UDSS is the demonstration secondary school. So these two schools have been like our pilot point for engagement, because the two schools are within the University of Benin. So these were the first schools that we went to introduce the ACTUATE project to. So every now and then we go to them to tell them about the progress of the work, and we try to stimulate their interest. We're using discussion sessions and all of that. So in fact, we even have representatives from the two schools as part of the Uniben ACTUATE team. So the collaboration between the two schools and the ACTUATE team has been very, very, very productive. So having gone through those different engagement sessions, we have seen that the impact has been significant. The engagement sessions that we have had, they have been very, very fruitful and productive. The abattoir operators, they have indicated interest to work with the Uniben team. They want to deploy biogas plants at the abattoirs, which they will use for heating purposes and for sustainable, environmental friendly roasting of their cattle for beef production. The farmers have indicated very high level of acceptability. They will love to use digestate. Some have even considered the possibility of even making a business out of it, to bag and process and package digestate for sale. Many of the undergraduate students that have been working with us in this project, they have many of them have done their research project, the final year research project in the bioenergy field and waste management. And some of these students have graduated, while some are still in school. The primary and secondary school students, they have had their interest stimulated significantly, and many of them want to pursue careers in the bioenergy space in the future. So the impact has been significant, and then people are really now seeing the usefulness of waste. Not that waste should be something that we should throw away, but waste is something that is important, something that is useful, and something that we can derive value from. Also, the institution, that's University of Benin now, has been very supportive of what we are doing in the ACTUATE project. The team lead, Professor Lawrence, is always in communication with the Uniben VC, intimating now on the progress of the project. And not long ago, the university, the vice chancellor and that management team, they actually visited the ACTUATE project, and the vice chancellor made very positive observations, very positive comments, and she was very, very happy at the level of work that we're doing. And she indicated that, in fact, these are the kind of things that we should be doing. This is the type of project that will take Africa to where Africa needs to be. And generally, they indicated a very high level of acceptance, and they were very happy with what we are doing. So moving forward, we are looking at how we can have business cases to see how entrepreneurs and small businesses can adopt this, either in the sense of bioenergy, waste management, or even digestate. So depending on which of the streams they want to look at. So there are business opportunities. Obviously, the abattoirs, they have already indicated a high level of interest. The smallholder farmers, even researchers, we are looking at a situation where the ACTUATE, the biogas plant, will become a very useful research tool for postgraduate students, where they can come and use that as a sort of like a plant where they can gather data for research purposes. Then even the schools around, we have had a whole lot of positive interest from them. then as well as the rural communities. So these are some of the things that we have been doing in recent times. And in summary, from the engagements that we have had, the interest is very, very high. There is a very high level of acceptability, and in rounding up, I would say that the future it looks very bright. So thank you very much.
I think I cannot help but echo Joanne and Keck's sentiments that this is absolutely incredible work, absolutely fantastic. I mean, I love the fact that it's been co-development, it's been co-design. You've carried the community along, and for me, just the flavor of the youth engagement and young children who are Africa's future engaged on the project. I think for me, it's just phenomenal, really. And now I can't wait for my flight in a couple of hours. It's taking too long because this is absolutely exciting stuff, and I want to come and see this for myself. I think it's really good. I think there's a question for you, Andrew, that's just come through from Joanne, and the question goes, Joanne. So Joanne's question is, so either Andrew or Mike can respond to this anyway, maybe, or even both of you. What do you see as the main hurdles for the adoption of AD by abattoirs, or the use of digestate by farmers? Or is there no hurdles? What do you see as the main hurdles, or is there none? Mike and Andrew, what do you say?
Okay, let me. Okay, can I give a response?
Yes, you can.
All right. Okay. There are a number of hurdles, and those are the things that we have found out from the series of engagements that we have had during the course of the project. One of the main things that we found out from the very beginning was the issue of acceptability, social-cultural acceptability. Firstly, when people consider where this waste, the feedstock, where it's coming from, cow poo, in some cases maybe human fecal material, and all of that. So when people consider that, there is a level of resistance to using maybe bioenergy from that type of source. So that was one of the issues that we found out at the beginning. And that was one of the key drivers, the key motivation behind the series of stakeholder engagements that we're doing. So we were going out there to introduce this project. Many people were hearing about.
Andrew, you okay?
Okay. Yeah, I'm okay. So what I was saying, many people were hearing about digestate and all of that for the first time. So that was what was motivating us to try and break those barriers that we observed. So we did a whole of advocacy, a whole of enlightenment. We even used the media. We did programs on our local TV stations using pidgin, and so there were a whole lot of things that we did to try to overcome some of those barriers. So maybe Mike can add to that.
Okay, let me just add one point. Okay, yeah, one of the key challenge or hurdle is, for instance, in a typical abattoir, there are a lot of persons doing private businesses at the same time. And then if we are to introduce a biogas system, we will have to be thinking about how many outlets, for instance, how many fire outlets do we have to create from a typical digester. So this is a challenge. So, and we've also thought of it in a sense of, okay, if we are to make it sustainable, it means that we have to create clusters from those businesses. Okay, if we have, let's say, 50 persons in a particular abattoir, okay, maybe we could say five persons to man or to be catered for by one fire outlet, because they have a number of cattle that they have to produce a day. For instance, in Ikpoba Hill, abattoir, they kill up to 50 cattle a day, and for you to prepare these these cattle into meat. It means you have to roast them, you have to do a whole lot of things. And you can't be waiting for one person to finish off before you can't be waiting for one person to finish off before you roast your. So these are a few things that we've thought about. So if we are to relate to with them on this, we have to really encourage them to build themselves into clusters. So we're able to cater for each of these clusters in a way that it will not give rise to competition and unhealthy competition at that. So this is one area that we've anticipated serious challenge. Thank you.
Are there any other questions from the room? I think why we're doing that is.
Can
Yes,
I
please.
contribute?
Yes, Prof.
Yes, still on the challenges, what other possible challenge is that of funding?
Okay.
Yes, funding and the deployment of the project. And during the course of engagement, we have also found that one of the ways of solving that is to get government engagement, and to get government policies to drive it. Unfortunately, an additional project of ACTUATE, as indicated, provided for a high-level engagement with vice chancellors. And the vice chancellor of the University of Benin has agreed to host 15 vice chancellors after the annual conference to get a buy-in into an institutional deployment of this project. But going back to the abattoirs and the farmers, both the abattoirs and the farmers belong to different aspects of ministries. And so if we engage the ministries and have a policy formulation to drive it, we should be able to encourage some support funding for small farm holders and the abattoirs. And that's what we are doing at the moment. We have engaged the Ministry of Education in the Edo State to see how we can also involve some of the secondary schools in the mini deployments of this project. So the issues of funding will be addressed. At a larger scale, there's a conference, a pre-conference workshop that is coming up on the 29th of this month. It's on a circular economy, and it's being driven by the Economic Summit Group, who are part of the development plan of Nigeria. This project have already been introduced, and we intend to have a national buy-in. These are what we intend to do to get policy orchestrated towards the ACTUATE project. So for the abattoirs and the farmers, funding will get the government buy-in, support what they have. And at the educational sector, we get the chief executives to buy. Thank you.
So, Alan, is it okay? But I'd like you to go straight to the fourth question on the Mentimeter. Let's have some interaction with the room. And the question is around, if you were to build an AD plan for the end users, which of them will you choose first? So the idea is, everybody, if you look at your chat section, there's going to be a link to questions. And I'd like us to kind of respond to them. And let's have a conversation around those. I know John has a question.
So you just want question 4, Ake?
That's question 4, yes. Question 4, yes. Because I think the other ones have kind of been addressed by the conversations already. But I think I'm particularly interested in question 4 and people's views. So folks, if you click on the link on the chat section, it's a question that would pop up on the screen. I'd like us to think about, and let's hear what the room is thinking. And maybe I'll come back to Kek, Andrew, and Mike based on the responses we get on this question. And the question is, if you were to build an AD plan for the following end users, which of them will you choose first? Okay, no, this one, next one, that's the one, yes. So this is the question I'm asking. If you were to build an AD plan for the following end users, which of them will you choose first? Can we vote, please? Let's hear what the room is thinking. Then I will come back to Kek, Alistair, and anybody else in the room to get a feeling as to what's happening on people's responses and why are people choosing one over the other. So for some kind of interaction before I call the Ghanaian team to showcase their own plant. Fantastic. So if you had to build an AD plan for the following end users, which of them would you choose first? Is it abattoir operators, smallholder farmers, secondary school communities, rural communities, primary school communities? Please, can we keep voting, please? Let's get some more numbers on the platform. If you were to build an AD plan for the following end users, which of them would you choose first? Now, obviously, everybody's has got a need for an AD plant in one form or the other. But I guess the question is, which of these will you choose first? And I want to find out why, based on the conversations we've had so far. Can we keep voting, please? So this is very. So we're having a balance. Everybody's choosing everybody. I think I like Joan's question. So it says, is it a question of Joan? What was your question? Joan, could you come to me your question, please? It says evenly placed. I think it's very interesting. So, Kek, who have you chosen?
So, I chose smallholder farmers.
And why have you done that, boss?
Because, well, I mean, to be honest with you, I could have chosen any of them. And I think with poor primary school communities, but, you know, I think the balance, you know, shows that. But really, I mean, I think, you know, agricultural community produce waste. They can then take use anaerobic digestion to process that waste, but produce energy. But also importantly, there's a direct route of the digestate to the farms themselves. So in that space, you have a clear circular economy. Now, I'm not saying that wouldn't exist elsewhere, for example, in rural communities as well. But you know, that was my initial thinking.
Lawrence was going to come in. Lawrence, were you going to say something with respect to this question?
Yeah. I'll let me start with the even distribution. It has to do with the multiplicity of the benefits associated with the project. Every particular segment has a need for it. The abattoir, the smallholders, secondary. But if I voted for the small farm holders, but I also support the secondary schools. The small farm holders are very organized. It's very easy to deploy there. The secondary schools it's an area we need for propagation of the concept of waste to energy. So I think the multiplicity of benefit is what the evil nature is. Yes.
So it feels to me that they would probably have different priority benefits. And I think I like Joan's comment. Joan says, well, is it a question of who first, or is it a question of getting together a number of stakeholders holistically and providing a solution to them? So I would imagine the peculiarities or benefits to a secondary school might be a bit different from an abattoir operator. Is that the case, Kek and Lawrence?
Yes. You see, the abattoir, for example, will be particularly interested in the benefits that will accrue from the use of the biogas in the activities in the place, and at the same time benefit from the reduction of waste. So you see, there's an economic benefit, and that has driven the choice for that. Then the secondary school is a mandatory requirement for advocacy. You see, because that is where we must build sensitivity. They eventually grow up as farm holders, abattoir owners, and even rural community leaders. So they need to understand this concept from day one and begin to propagate. Yes, we need to propagate. Yes, it's very, very important. You see, you find out that most of the issues associated with waste generation and waste disposal now are borders on sensitivity, sensitization. Today, we can talk of segregation because the secondary school students have been exposed to the processes of ACTUATE. And we require segregation for proper waste management, both at the rural an urban setting. Yeah.
Very, very powerful. So, Kirk, I think I'm going to come back to your question now. So, just on this line, before I call the Ghana team, I did ask you a question earlier on. So, as the lead on the project, and I would imagine other people on the Nigerian team would have maybe a perspective around this. I want to know, now we have a plan. So, what next? What would make you a happy man, Kirk? Back to my question originally, because sustainability is absolutely crucial for projects of this nature. What we don't want is, we have a nice, beautiful plant in Benin. So what?
Yeah.
Kirk?
So I think, and Prof. Lawrence and others have actually touched on some of the things that make me very, very happy. I see it at several levels. So the first and probably most tangible level is as a university academic is, to be able to continue working with our partners. So that means that we would have to access funding to allow us to continue research, capacity building, to continue to affect change. And of course, Prof. Lawrence already touched on that. But so that's a very that's a relatively short-term thing. Well, in terms of getting a hold of money, it is anyway. But some of these projects can go on for quite some time. I guess then the next thing is thinking about the actual subject matter, what we're actually working on here, in the sense that see through this and other the projects that we're involved in, seeing organic waste actually being directed to bioenergy. Now that might be anaerobic digestion, it might be fermentation processes, whatever's appropriate, and that and that sort of notion of being taken up as a bona fide technology to process waste and of course produce energy. And climate change is upon us. COP26 is arriving. It's clear that there are challenges around hydrocarbons and fuels derived from crude oil and so on. So that's important. I guess in relation to this, to complete the circle, is the acceptance of digeste as a supplement to conventional inorganic fertilizers, which are often very expensive and sometimes not available or infrequently available, or indeed to replace fertilizers, conventional fertilizers, with these wastes. And then the final thing, of course, is actually the longer term. And Prof. Lawrence very eloquently touched on that with regard to secondary schools, but I would also throw in their universities as well, where we need to engage with the youth to really, really drive change. And we must be under no illusions that this is not an easy job. Okay, this is going to take quite a long time to engender acceptance within communities through the youth as these people leave education and set up their own businesses or end up working for people or whatever it might be. So, in the long term, if we see that real change, that would make me exceptionally happy, but I'll probably have retired by that point.
So I'm getting some good commentary from conversations and discussions on the chat, which is fantastic. So Tony talks about is choosing secondary school because obviously of the education element around the project, which makes sense. And then I can hear Joanne speaking about the fact that on the back of this, going forward, what we've done needs to be promoted. People need to hear this message, much bigger interest, much wider interest created. And I think I like what Dorothy, who is the president of the Nigerian Aeronautical Society, she's just about the fact that everyone belongs to a community, whether you like it or not. I think in some sense, it's easier to get a buy-in if there's a bigger umbrella of collation for the impact thereof to be tangible and significant. And very, very impressive work, guys. I think at this point, I would now call on our Ghana friends to showcase Ghana. I'm looking forward to this one. Fantastic. Over to you, Richard. I know Richard is not feeling too well, but he's handed the baton over to our great friend Kofi to take the lead. I think they've got a pretty impressive video to show us. It just shows us what they've been up to. Over to you, Ghana.
Akan, do you want me to share the video?
Yes, Alan, you can share the video. That was the agreement, so you can share the video from your end.
Yep, that's fine. I'll do that now.
So they only have a video, which is fantastic. So after the video, then I'm going to interrogate Richard and his team, if I may. And so folks, have any questions to ask Ghana team once you watch the video, please feel free to raise your hand or drop a message on the chat. Let's go.
Can everybody see that? Can you see the video?
Yes, we can.
Excellent.
Yes, we can.
African countries continue to grapple with waste disposal and management, a state impeding its developmental agenda. The continent produces thousands of tons of solid waste daily, with most ending up in open dams and wetlands, contaminating surface and groundwater and posing health hazards to majority of its people. In most African countries like Ghana, waste management is largely at the district, municipal, and metropolitan levels, where waste is sent to landfill sites, which are gradually becoming difficult to manage technically. Compounding the situation is the non-availability of land for such purposes. To turn the tide around for the continent, Lancaster University, with her development partners 4 years ago, embarked on a project known as RECIRCULATE, a circular economy in which waste and resource management contributes to a resilient environment and human well-being, making use of reduce, reuse, recycle, and repair or refurbish. The success of that project is what has led to the introduction of what it now terms as a relating the adoption of circular sanitation demonstration systems for improved health outcomes, simply dubbed ACTUATE.
The ACTUATE project is designed on the premise of having to solve or contributing to 3 particular SDG. SDG 3, which is good health and well-being. SDG 6, which is clean water and sanitation. And that of SDG 7, which is affordable and clean energy. The project simply looks at a paradigm shift of waste to wealth and also shifting attention from having to manage waste at the municipal level to managing waste at the institutional level. And what we have done is to construct 2 systems, one in Ghana, one in Nigeria.
This is a biogas setup, which we have done for the school. And a biogas setup just means that something which can give you the biogas. So compared with what we have in our homes, we have the LPG, which is also a gas. But then the biogas now comes from anything that can ferment. So if we take our homes, for example, the things that in the kitchen, if it is food waste or peels, all of these can ferment, and then it can go into our system to then give us the biogas. So this is just like an engine generating your own biogas in your vicinity. So here, because it's a school, then we're looking at using the school waste, the ones which can ferment. So you have this as the main engine, which is called the digester. But like every animal or human being, you have an inlet like the mouth. So everything will go through the one up there, which is the inlet like the mouth. Then it will come through to the main digester, which the engine is. So there are microorganisms here. So they feed on the organic matter that goes in here, and then it gives us the gas. The gas that we give it, because it's coming from things that ferment, then we call it, that's the biogas. And it's energy just for cooking. Slightly different from the LPG, because the LPG is pressurized, but this one is at a low pressure. So in terms of safety, this one is safe, and then you would have generated it from your house. This is powered by energy, and we're using this one up here, which is the solar PV system. So it means this can be done anywhere, not only in places where there's electricity. Where there's no electricity, this will generate itself, and then for this one. This is only a demonstrational site for the school, but they can have bigger ones. The matter of garbage in, garbage out. If you want to use the same containers, there are bigger ones. You can have about a 10,000 liter one, and then it's modular. Modular means that you can connect them in series and in parallel. This is also a part of the curriculum in the children. At the SHS, you open your textbook, it is there, renewable energy, and then they talk about biogas. So this is a demonstrational part which fits directly into their academic curriculum. So it's not only about learning book, but now they'll have this here. So we're doing it with the school. The teachers are part of it, and then the students themselves are part of it, so that they learn and then inculcate into their habits with the hope that as they grow into the future, they will be able to take it up. Right, so this is called a macerator. It's just like the blender, which is being used in the kitchen. It's for grinding the waste that we can. So let's say if you have leaves or it's, let's say, banana peels, you can't use the big size. It must crush it because the microorganisms that will feed on it are tiny. So where it is crushed, and then it is motorized. This is simply to make sure that once you open, then it cuts off. Okay. Once it crashes down here, we open this unit, and then it will go through to a mixing chamber at this point. From this mixing chamber, then we will need to send it up there. So sending it up there means that we need to pump it to the extreme end, that is the inlet. Because up there you have the solar panel, which takes the energy from the sun. The sun's energy must be converted to electricity. And this is the device that will connect the sun's energy into electricity, which then can power the system, the pumps. But then these are batteries, which then can store the power, because when the sun is not shining, we still need some power. So the battery then stores the power so that then we can use it for our system. This is a small size which has been designed to be able to work on the system. But if you have a large setup, then it will increase the capacity of the battery and then that of the inverter. Yeah, this is the stirrer. It is connected from here to the top and in there. So once you turn it, it stirs or makes up what is inside there. If you do not stir, then you're going to have the solid part settling down and then the liquid part staying up. But that will not make it efficient. So you rather have to stir, and then it's a matter of just stirring slowly. You can do it, let's say, twice in a day, sometime in the morning and then sometime late afternoon. So it's purely just mechanical. This system is specifically built here on the septic tank, because the idea was the septic tank itself is just a holding tank. It does not treat the waste. And currently, Ghana's building code does not even subscribe to the septic tank. It talks about on-site waste treatment. So here, we're turning the waste from the septic tank into an on-site waste treatment by introducing the biogas. So apart from the waste that the children can add from here, then the toilet waste, which is in this block, this building, as the toilet, comes into the septic tank, and then it picks from the pump. We have a pump here at the bottom here, which is connected to the septic tank. It takes the toilet and then brings it to the system. And we have put it on the system here specifically because we don't have enough space. This is all the space that we have. So if we wanted to put this in the ground, then it means we would need to break the wall. But then the alternative was to mount it on the septic tank. And this is specially designed because of the lack of space here. So the system that we have, so that it will generate the gas. Where is the gas stored? In this particular setup, we're not storing the gas in the system, but then it is stored externally in a gas tube. So this is the gas tube, that's a 5-meter cube that we're going to use to store the gas. So the gas will come through a gas meter, which we can use to measure the flow. And then we have the desulfurizer, which is also a cleaning material to remove some of the unwanted flows in the gas. So the gas comes from that far end, and then it is piped underground through the safety check valve there to this point. Then it comes into the storage device here. Then from the storage device, it then goes through to the wall and inside to a show lab, which we would see what goes in there. Okay, this is the end use of the gas. That is where the gas finally comes. You can either use it for cooking or you can use it for lighting. And they come through a pump here. The pump will just maintain the pressure that is required. It's like the balloon that we have at the back there. It is not pressurized. It's only just to the size of that's the atmospheric pressure. And that is one of the reasons why it is not dangerous. So there's a need for a booster, which is the pressure, which is just generated by, there's a 5 watts. It's very small, so it does not actually consume so much of electricity. And it pipes through to this. This is a biogas stove, slightly different from the LPG stove. So if you want to replace this with LPG stove, it will not work unless we have to change something about it. For lighting, then it goes into this one, which is the gas lamp. The gas goes into it. For those who are old and have seen the use of the kerosene lamp, which you had to pressurize and then light, that is a very similar technology. That one was kerosene to light, but this one, it's gas to light. And it can be used in a place where there is no light, because then you have generated your own light. So this is a self-sustaining project. It has a lot of benefits. It's like you generate your own energy. So it's even part of, you can term it as a poverty alleviation, because the amount of money you would need to go and buy gas or go chasing for firewood, now that one, it's not going to be done, because now you generate your own energy. So it's only about maybe the initial cost that you would need to set this one up, and then that would be the cost. Then it becomes beneficial. We can do for community and then pipe it to the houses, just like we do, let's say, even water or electricity. So you can pipe it to the houses, and then there are meters which can be put on them. This system was designed by CSIR, Institute of Industrial Research, with the support of Lancaster University. So everything works. Like the tanks, yes, we bought them, and then the solar, the panel, and the inverters. But then we put them all together by scientists at CSIR, Institute of Industrial Research. And this is modular. We can always do bigger ones, whether it's above ground or to be underground.
Now, ACTUATE is talking about renewable energy. You see, you have organic material, which is coming from living things, is coming from plants. So that organic material is converted into energy. That energy is used for agri activities. The biofertilizer is used for agriculture. The fertilizer is used to produce foodstuff. The foodstuff is what we eat again. We eat, we generate waste. That waste is not waste, it's a resource in an ACTUATE sense. So it's in circle. So nothing goes to waste, because everything that goes through that digester, you harvest it back again. So it's in a circle, so nothing is waste.
We went into the community to find out the perception of the people about waste management and also the waste management practices that they undertake. So some of the findings we came up with was that waste segregation was not a thing for them, unless maybe they have a purpose for it. Let me give you 2 instances. They segregate pure water sachet just because there's market for it. People come around to buy them. So because of their relationship with livestock owners, they also segregate, food waste. We also had to do some education. We sensitize them about the importance of segregating waste. The issue about the circular economy, the people down there are not all that familiar with. But we made them understand that waste is not actually waste, but it is energy in transition.
We all hear about climate change, but then how does climate change impact us, and how do people know that it is really impacting our lives? So ACTUATE was featured as one of the local actions that was promoting climate change activities in our communities. So we got our policymakers in there, we got our parliamentaries in there, and we got other local government officials in there to understand and to appreciate how best this whole project can be replicated in other communities, because they feel the impact of climate change the most. And then the waste generation and sanitation issues, they are the ones who do it the most. And we would say that even though the impact of awareness creation projects are not really seen immediately or felt, we believe that the ACTUATE project was one that has really had two main impacts. First, our stakeholder engagement strategy has refocused the discussions around biogas technology among industry players and high-level officials. And also, the ACTUATE project, at the end of the day, has made us to be able to get in touch with the community.
So far, Green Art has been able to renovate a space in the school into a show lab where the gas will be connected directly into. So as part of the training given to the students, we went through a couple of presentations to get them to understand what waste is, how they could segregate their waste at home, the types of waste they normally find at home, and how best they could bring it to the school. So these pails you see behind me is what is being given to them to take home. The household or food waste they generate, they would put it in the pail, bring it over to the school, feed it into the digester, which would help generate the waste, the needed power that will be shown in the show lab.
This particular project is leading to a science resource center, or what we call a show lab. And as a school, instead of just the experimental purposes of conversion of waste to gas and the usage, we are, Lancaster, and for that matter, the funders are virtually turning it from that, first of all, being just for demonstration purposes to a science resource center to enhance the teaching and learning of what? Science.
We as students are asked to bring some waste products from the house so that they can be used to feed the biodigester. Fermented waste, example, leftover banku or dokun fruits. They told us that when we feed the waste products into the tank, it will process it into a gas so that it can use to power the science lab, the show lab over there. The digestate, which will be left inside the tank, we can use it to feed our crops as fertilizer.
These are some of the things they told us about. It will help us to reduce the number of refuse we produce in our homes, how to keep our environment clean. And that has been what I deliberated to do, to become a scientist or a doctor in future. And this thing has helped me a lot to learn more about the world.
I want to really congratulate the implementers of the project. Community consultations actually went on. That's the most exciting part of this whole project, because I realized that the implementers of the project had to meet religious leaders, both the Muslim, the Christian faction. They also had to meet opinion leaders, that's the assemblymen, the chiefs, and and the sub-chiefs within the community-based organizations, and then youth groups within the community through a DEBA, and then explain everything into details. They actually also did that using local languages, to explain the concept of the project. So everybody within the community knows exactly what is going on and what is actually going to come out of the project. And we're going to protect this initiative and also try as much as we can to, in one way or the other, talk to our younger folks to take whatever courses that are going to be given to them in this school, for as far as the project is concerned, serious, because then we want in the next 10 years, we should actually be having scientists from within us who are actually championing projects of this kind.
Okay, I think it seems to have stopped. I think that's just fantastic. Can everybody hear me okay? Yeah. Can everybody hear me okay?
I can hear you. I can.
I think I was just smiling when I read Joanne's comment when she said that it's quite nice to see an AD plant for real. I've been hearing a lot about it. And I'm just smiling because I think I feel the exact same way, to see one for real, and maybe to see one on this call, but later on to be touching one for real. I think, I mean, when I was in university, I never imagined that would be the case, but imagine how those young kids feel at the secondary school level to have access to something that powerful as a learning, if like facility, as they grow and get conscious about the environment. I think that's just so cool, so phenomenal. I mean, I'm losing words to describe the impact of this at that level. So I guess I want to kind of open the room up for folks to ask the Ghana team some questions. Obviously, what they just presented, just like the Nigerian team, hasn't been easy. Maybe I'll start first. So Richard, you've taken the lead on this. Can you tell me what kept you up at night? What gave you endless headaches, which nobody saw as the person living on this? What were the biggest challenges for you? Because I'm sure it mustn't have been an easy ride, but what was it? Richard, please.
Yeah, thank you, Akan. The biggest challenge for me and for the whole team was that this is the first time that we have built this facility in Ghana. We have been building biodigesters since 1992. And all the digesters that we built, we put them on the ground. We bury them underground. We haven't done surface biodigesters before, let alone...
Oh, you're breaking up, Richard, a bit, I think.
I think my internet is a bit low. I was saying that the ACTUATE this thing design is different from what we have been doing all over the years since 1992. So we were thinking, what we are doing, we haven't integrated a solar system with our biodigester system where we have to use pumps to lift material from one point to the other. We haven't done it before. So that was our main challenge. And most of the things we have to fabricate from our engineering shop. If you look at the macerator, we have to fabricate that one from the scratch. We have to think, how do we copy the blender system to do that facility? And how do we make sure that the safety device there works? Where we open the cast, the blade, when we put it there, it continues. So all those things went into the headache that we have to go through. But thank God the scientists were able to overcome all these problems. We have set up the facility. It's looking very great. So in our next meeting, and then you see the lantern that we put in the show lab, bright and showing the power of conversion of organic to energy, so that we'll all be happy about what we do. And I might also confess that the COVID has actually disturbed most of the activities we plan to do, because we actually wanted to integrate the children into even designing the facility. We wanted them to be in our lab. We wanted them to be part of us when we are even doing the initial drawing, even when we are doing the construction in our workshop. We wanted them to be part, but the COVID didn't allow us. So they were not part of those crucial activities. But we have documented all the stages that we'll play back for them in the show lab so that they'll follow the steps from the beginning to the end. Thank you.
I think that's absolutely fantastic, Richard. Thank you so much, man. Any questions for the Ghana team, please? Any comments or commentaries? I think there's a comment. So Clifford says the impact of the project is quite huge. Let me just pick up Clifford's comment. So he said the impact of the project is very huge, and from the presentations from both Nigeria and Ghana, it shows the more the showcase is needed to drive aggressive adoption. So I think you are very, very correct. And I think it's the reason why it's actually a demonstration / showcase project. Is the fact that things are done in laboratories, things could be theoretical, but actually things can be touched. You can touch it. You can see the reality. It's actually working. You can actually see the waste going in somewhere. You can see this nice, beautiful bag, digesting it. You can see an extra bag with the gas going in there. You can see a generator, and you can see light. I mean, it's that practical. That's the beauty of demonstrations or showcase projects like this. Now, a question from Joanne. Joanne says, what are the key challenges in creating a relationship between the demonstrator and for other communities to be able to create their own digesters? Richard or anybody in Ghana, could you respond to that? What are the key challenges in creating a relationship between the demonstrator and for other communities to be able to create their own? I would imagine that a good legacy would be that people come and see this, and then they want to go and do their own. What's that relationship, or what would be the challenges for that to happen? Richard, anybody?
Yeah, okay. This is Kofi. I respond to that. This work has been done where the headmaster who is on this platform, so Mr. Imoro, has played a very key role. He has served like the media relation, if I say, between the research scientists, the CSIR, and then the community. So he has been organizing programs for the parents of the school children and even the community people, because I've been part of it, which I have been there to do the technical presentation of the biogas system and how it can be used in the homes and even in the community. So he stands as either a middleman or a PRO. I remember at one of the presentations, one of the imams took my contact and he said he would contact me later so that then he would see how we could support them in their community. So we don't have a challenge as such, because then once they get in touch to the school, they can easily have access to us. And we also have our contacts available that we can also help them. So I don't think we have a challenge.
Interesting. Okay, that's fantastic. I see your point. Okay. Yes, I think someone's hand is up. Japhet, could you go on, please? I see your hand is up, Japhet. Let's go. Japhet, unmute yourself and proceed.
Can you hear me? Hello? Hello? Hello?
We can hear you.
Hey, that's it.
Can you hear me, please?
Yes, we can.
Okay. I said I guess the question regarding challenges in terms of having to replicate this project around the nooks and crannies of Ghana, right?
Okay.
Yes, first of all, I
that's
think
fantastic.
we need to consider the issue
Can I ask, just for the sake of the audience?
Okay.
No, go on. Japhet, go on, please. Thank you.
Yes, I wanted to say that Mr. Imoro has done extremely well. He's, as Dr. Pnefo said, he has served as the liaison person between the community and the project coordinators or the scientists. But I guess replication in the communities would also depend largely on policy influence and dissemination. I think that for us to be able to replicate this, as I said earlier, in the nooks and crannies of Ghana, policy would have to be influenced for the district assemblies in terms of district, and even at the metropolitan level, to be able to adapt this particular technology and try to replicate it. And so dissemination is key at this point. Having to engage the people to be able to understand the technology, know the challenges that comes with the technology, and also be ready to accept adaptability is also very important. So far, so good. Madina Zongo's project has not been bad. It's been very successful. The acceptance level is very high. Parents have actually understood the concept. Another challenge that is also being faced, as I can say, is the issue of financing the project. You know, having to get smaller units, okay, that are applicable at household levels, and then could be financed by individuals who own these households. So the two, policy influence and then the issue of finance, is what we need to look at going forward, so that people can easily adapt and be able to adjust themselves to the use of these technologies.
I think that's fantastic. I think I'm going to ask, thanks Japheth for that contribution. I'm going to ask a bit more general question. So, I mean, it's one project as it is. I mean, I understand the fact that there's something happening in Nigeria, something happening in Ghana. What would be bad though, I think for the sake of the audience as well, is for it to look like two different projects, because it's actually one project. So I'm directing this to Kirk and maybe to the lead in Nigeria and Ghana. Are there plans to learn from each other or to integrate things better? Are you following me, Kirk?
Yes, I'm here. Thanks, Hakan. Yeah, I mean, I think that is an important point, the question that you ask. I think, you know, within the Actuate project, we have made some funding available for many projects, and there are plans afoot for the teams from Ghana and the teams from Nigeria to visit the respective demonstrators. So I'm not being very clear, but the team from, for example, the team from Ghana will visit the Uniben team and you know, inspect and see the demonstrator there, and vice versa. And of course, there also opens up opportunity for workshops in both locations as well, not only with the research teams, but also with wider stakeholder community as well. And I think that's actually a really very important outcome from, you know, before the project finishes at the end of the year. So yes, that's in train. Yeah.
Thank you very much, Kirk. Anybody else want to say something? I think the Ghana team. I do know that Richard is planning to go to Nigeria. Richard, what's that about? Why are you going to Nigeria? Can you let everyone know?
I can.
Yes. Why are you going to Nigeria? Just for the sake of the audience, you have a plan to go there, to go and
yeah, we are. Yeah, no, we are planning to go and then do a technical knowledge exchange. We will go to Uniben and look at their facility and learn at hand from what they have done. Because they have put there, we also have not put that type in Ghana before. So we learn from them, we learn from their technology, we learn from their strategy that they use in their community engagements. Then as usual, I'll eat some eba as well before I come back. Then they will also come together and do likewise workshops together. Thank you, Akan.
Thank you so much. So it sounds good. So it's not only you going to Nigeria. I think I can see Mike smiling because he's looking forward to coming to Ghana as well with Andrew and the team to come and check out what is this beautiful noise you've been making about this gorgeous plant in the primary and secondary school. I think that's absolutely exciting. Are there any commentaries before I call on Keck to wrap it up? I think it's been a good showcase. People get a feel as what's been going on in Nigeria and Ghana. If there are any questions and folks who want to follow up on the conversations afterwards, please reach out to the planning team. And before I close up, I want to call up Mr. Imoro Suleimana, who has been the the lead in person at the school in Ghana. So to make some few remarks. Over to you, Sulemana, please. Sulemana, please, could you unmute yourself and proceed? Is he having a problem with his microphone or something? Or can he hear me? I saw his hands went up. The head of school at primary school itself. Suleiman, are you there?
I think he's having problems, Akan.
Okay, probably having problems. So I maybe we can pick up from here. I think okay, he's left. I think he just left the call actually. Kirk, could you wrap this up? So give us a feeling of how you feel. Just wrap up this show.
Hello, can you hear me? Hello.
Sulemana is back. Are you back?
Hello, can you hear me?
Yes, we can.
All right. Thank you very much. Yes, with respect to the question that was asked, and then what Kofi and Jaffe said, we've done lots of things to get information down to virtually everybody. If you look at the media engagement that myself and Kofi did with Net2 TV, it went across the country, and then many people called in to find out about the project, and then Kofi left his number for people to get in touch if they were interested. So I believe that what is left in that regard has to do with possibly funding. And what Jeffrey said about the policy influence. So having looked at that area, I've submitted a proposal to Lancaster for the additional funding component that I will be bringing together all head teachers within the municipality, all assembly members within the municipality, the municipal chief executive, the municipal director of education, chiefs, within the communities, so that these groups of peoples, individuals, they are the policy makers and they are the decision makers who believe it will get them together on such a bigger platform, and they will communicate this message. Hopefully, they will go take decisions on that, and then we'll see the replications of this particular model that we're talking about. So that's what I would like to add. Thank you very much.
So much. Okay. Could you wrap up? I think it's been a really cool showcase. People actually see that what we've been doing for the last couple of years has been real, and then we can actually progress to the next level. Over to you, boss.
Thanks very much, Akan. Well, I mean, first of all, I'd just like to thank everyone for attending, but I'd particularly like to thank the team from UniBen and, of course, the team from Ghana for fantastic work over the last 2 years, and of course the fantastic presentations as well. I mean, this for me is the first time I'm seeing this in this way, and it really does show just how much work everyone has put into getting the projects to where they are. It's absolutely amazing, in my opinion, because it's one thing being able to do experiments in the laboratory. It's quite another taking that to real life, to full application, and the ramifications of this project are coming to fruition, in the sense that there's lots and lots of interest from the wider community, newspaper articles, web articles. We've been invited to present the outputs from the project to a much wider, almost an international community. There are ramifications for this for climate change and COP26 with government as well. It really is very amazing. So absolutely fantastic, and we mustn't forget, as I've said before, the support that has come from institutional leadership as well in this. It is truly amazing, and a real example of genuine collaboration across the piece. So thank you, everyone. For me, I've just been blown away today, and we know that we're having our annual meeting next week, which is going to be quite intense. But I think that will again show the research community exactly what has been going on and how fantastic the project has been. So yeah, there are so many opportunities going forward from this, and we must take advantage of these. And we're already starting to look at new opportunities for funding through the European Union and Horizon Europe, but also elsewhere in sub-Saharan Africa as well, through, for example, the African Development Bank and so on. So I remain very, very optimistic that we will continue on this journey. We will continue to collaborate and work together, and we will ultimately, through these projects, make a tangible impact and make a difference at the end of the day. So that's all I really want to say. As a director, I'm extremely happy, big smile on my face. I don't smile very often, but yeah, I'm really happy about the outcomes that are, coming from these projects. So well done, everyone. Thank you very much, and back to you, Akan.
Thank you so much, Kate. That's absolutely fantastic. You've been blown away, and I can feel the wind on your face. so I think everybody listening to us, if you look at the chat section, Diane has graciously left a link. If you want a certificate of participation on this webinar, and please just click on the link. It should ask a few questions about yourself, how you want your name to be shown on the certificate, and then we'll respond to you right away in the next couple of days. And also, if you want to subscribe to our newsletters, we have some very exciting new projects happening, some new funding opportunities has come through, and we want to keep you abreast with what is happening at the Center for Global Eco Innovation in Lancaster, but also things happening with our different partners in different African countries. So subscribe to our newsletters, and we'll get you some information as these newsletters do come through. On that note, thanks to everyone for joining the session today. Thanks for your participation. Thanks for your audience. Thanks to your Nigerian and Ghanaian teams for doing an incredible job. And have a lovely week, everyone.
Thanks, everyone.
Thanks,
Bye for now. Bye.
Thank you. Bye.
Thank you. Bye, everyone.
Bye, everyone.